So far, we have looked at the univariate frequencies, just counting each variable on its own. Then we looked at the two predictor variable, single outcome variable relationships, survival by gender and survival by sexual activity. We now want to complicate things even more and ask, with the two predictor variables, do they have, what relationship, what pattern do we see on the outcome variable? So we want to know about survival by sexual activity and gender. We want to know if the pattern of survival is the same within the men who are sexually active and not active as it is within the women who are sexually active or not active. Whenever we're exploring the effect of two predictor variables on an outcome variable, there are two different patterns that we might be looking for, that we are looking for. One of the patterns is called additive. If the variables are additive or share an additive relationship, it means that their effects just add together. The level of one variable doesn't influence the effect of the other variable. Each variable has an effect on their own, and those then add together to form an additive effect. The other possible pattern is an interaction. If the variables interact, then the effect of one variable differs depending on the level of the other variable. And so in this case, they don't have the same pattern, they have a different pattern, and we would call that an interaction. Let's go ask that question. Is there a difference in survival rate between the genders based on sexual activity? Or does sexual activity have the same risk for both genders? Did you hear which one of those was additive and which one was interactive? Does sexual activity have the same risk for both the genders? That's an additive statement. Is there a difference in survival rate between the genders based on sexual activity? That would be implying that there might be an interaction. Let's find out. We're going to need a contingency table that is survival by gender and sexual activity. There are a couple of ways of doing this, but it's probably easiest just to kind of think about it as two separate 2x2 tables. Let's start by focusing on the males. We're going to copy the levels of the outcome variable and then the total and the percent. Let me make a note that we're looking just at the males right now. So within the males, this is going to be survival, gender, and sexual activity. So within the males, survival, the third variable we need, oh, it's that sexual activity, isn't it? Let me copy and paste those. So in this cell here, I want if male and sexually active and survived. Sounds like a count ifs. Insert a formula, it's still right here. Count ifs. B male and column C is present and column D is survived. I want count ifs. B is male. Do you see how it's saying number name question mark? And that's saying, I don't like that. That's not a number. Now, this version of Excel will add those quotation marks for you, but older versions won't. You'll need to add those yourself. C is Where are we? Sexually active and died. Present and D is died. Let's do those counts for the not sexually active. I've highlighted them and filled down, so that's filled the same formula. I'm now going to go and edit my criteria. So this one we want male, we want this to be absent and survived, yes. And for this cell we want male and absent and died, yes. Let's calculate our totals. Have you got a favorite way of calculating totals yet? And calculate our proportion survived, the number that survived divided by the total. We now have half of our contingency table. For the men, we've looked at survival by sexual activity. We now need to do the same thing for the women. I bet we can copy and paste and make our lives easier. So for the females, what are we going to need to do? Oh, we're going to need to add the letters phi for female. Enter, accepts it. Tab takes you to the next one. Oh, that should have updated. That should be fine. Add the word female. Enter accepts those changes. Tab takes you to the next cell. Enter accepts those changes. And because our formulas were dynamic, they have all updated with the correct data. Go ahead and verify for yourself that has happened. We've now calculated the 4 data points that we're interested in. The percent survived for males based on sexual activity and the percent survived for females based on sexual activity. We need to just recombine those in a way so that we can plot those. Let me go ahead and copy that survival by gender and sexual activity. And we're going to have males and females as our levels there. And then sexually active and not sexually active as our labels there. To fill in this contingency table, I just want to set each of these 4 cells to equal one of these 4 numbers. I could use paste special, but it's probably easier just to, let's say that I want in this cell is males, sexually active, survived. It's that cell I want. And then males, not sexually active, that survived. That's the cell I want. Equals females sexually active survived equals females not sexually active survived. Now that data is all clustered into a contingency table that's going to make it easy for us to plot those 4 data points. I've highlighted them on the insert ribbon. I'm going to choose a clustered column. And there's our between the males and the females, sexually active, not sexually active, and the outcome is survival. Let's go ahead and format that. The first thing I want to do in the formatting is to look at the switch plot or the switch row column and see which organization tells the clearer story. So this story is within those who were sexually active, here's the male survival rate and here's the female survival rate. within those who are not sexually active, here's the male survival rate, here's the female survival rate. Let's see what happens when we switch the rows. So now this says, for the males, here's the survival rate for those that were sexually active and not active. For the females, here's the survival rate for those who are sexually active and not active. I prefer this way. I prefer having that fixed quality of gender, male, female, along the x-axis in this case, because it just seems to make more sense to me to say, of the males, those that chose to be sexually active, or those that were cast to be sexually active, this was their outcome. And of the females, those based on that sexual activity, this was the survival outcome. That just makes more sense to me than saying, of those who are sexually active, here's the outcomes for the males and the females. But either of them are perfectly legitimate ways of telling that story. You need to make your own mind up. I'm going to move the legend. I'm going to add titles. Remember, if you switch the plot after you added the title, it doesn't warn you about that. So I'm going to say this is by gender and sexual activity. Couple more things. Take away some of that clutter. Make sure it's got a 0 baseline. Oh, I don't like those colors because it's blue and orange. Those are on opposite sides of the color wheel. We can't use meaningful colors like blue and pink for gender because we've got our genders clustered down here. If you chose to put gender up here, you might use blue and pink to indicate the gender, but also remember that if it's turned to grayscale in a print, that's not going to show up. Let's just go to our normal monochromatic. Excel has put a little tiny gap between these two columns. Is that important? Is that correct? Take a moment to think about it. Do you remember the rule? Do you want to go and look it up in the glossary and design guidelines of when you need a gap between columns and when you want your columns to be touching? Did you look it up? Or did you just want to hoping that I'm going to tell you the answer? I'll tell you the answer. Because sexual activity, sexually active and not sexually active, are categorical variables, that there are two distinct categories, we want a space between those. If they were touching, it would imply that they were continuous, and that it would be sort of, as you move from one level to another level, one value to another value. But as these are pretty distinct categories, we really do want them to be separate. Now, if Excel had not put a gap in there for you, let's see how we add that. So by clicking on one of the sets of columns and coming over to the Format Data Series formula bar under the chart options, it's saying, do you want these to overlap? And there's a negative 27% overlap. So if I say 0 overlap, that should put them right next to each other. If I said positive 27 overlap, that's going to actually overlap them over each other. Wow, that's really bad. A negative 27% overlap means that there is a space between them. The gap width must be this space between the genders. Let's see what happens if we say, let's put that down to 100. And so it's increased the column size in order to decrease the gap between. I think I actually preferred it the way it was before. Let's see if we can undo that. It's not letting me undo it. I'll just put it back. What was it? It was about 250, wasn't it? When you're happy with your formatting, go ahead and copy that and paste it into your document. When you write your sentences in your write-up, you're going to need to interpret this. Now, remember at the beginning I was saying, we're asking the question, does the effect of sexual activity just add together with the effect of gender? Or does the effect of sexual activity differ depending on the level of gender? In this case, we can see that the effect of sexual activity differs depending on gender. Within the males, being sexually active made you slightly more vulnerable to being killed. That's a difference of, what, about 5% decreased survival rate. However, within the females, the difference between being sexually active and not sexually active was much greater. It's a difference from 28% down to 13%. So it's, my goodness, it more than halves, doesn't it? So if you are male, it doesn't really matter much if you're sexually active or not. If you are female, it makes a huge difference if you're sexually active or not. So we would interpret that as an interaction, that the variable sexual activity differs depending on the level of gender. Another way of thinking about this, if you were to draw a line from the males who were sexually active to the females who were sexually active, and then if you were to draw a line from that very top middle of the males who were not sexually active to the females who were not sexually active, you can see that those lines aren't parallel, that the line here is not parallel with the line here. And that's giving you another indication that that is an interaction. In your write-up, you will need to discuss all 4 pieces of that data. I recommend that you use very simple sentences, that you try to be very repetitive. Keep the variables in the same order and just discuss each data point in turn and keep a very formulaic, repetitive, simple sentence structure. Don't try to cram too much information into each sentence or into each paragraph. That feels like we're about done with this data, that we've really analyzed this data and have identified the patterns that are of interest.